In this video, we'll take a look at how to create a service client in C++. To start, we'll need to add the TurtleSim package as a dependency to our RJ training package. To do this, I'll add a line to the package manifest that adds a dependency on the TurtleSim package. And in the CMake file, we'll call findPackage with this TurtleSim package name, and then add TurtleSim to the list of dependencies given in the ament target dependencies function. With that new dependency, we'll be able to use the services defined in the TurtleSim package. Now we'll write a new node that sends a request to TurtleSim's spawn service. Here's what that node looks like. We start the same way we write all ROS2 nodes in C++. We'll define a class for our node that inherits from our CLCPP node. To make this node act as a service client, we need to add a member variable that will hold an RCLCPP client templated with the type of the service. Note that to use this service type, we had to include its header file from the TurtleSim package. Now that we have this client variable, we need to initialize it with the createClient function. When we call createClient, we give it the type of the service and the name of the service. It then sets up everything we'll need under the hood to call that service. Now to call that service, we're going to have to send the request and wait for the response to come back. If we did this in our constructor, it wouldn't actually work because our main thread would be blocked and there'd be no opportunity for the ROS event loop to run. To solve this, we're going to call our service from a new thread. So we create a thread and bind it to our sendRequest function. Because we're not particularly worried about managing the lifetime of this thread, we'll just immediately detach from it so that it can automatically clean itself up when it's done running. Inside of the sendRequest function, the first thing we need to do is make sure that the spawn service actually exists. We do this by calling waitForService, and we give it a timeout for how long it should wait before giving up and reporting that the service doesn't exist. In this case, we're setting that timeout to 10 seconds. If the service doesn't exist, here I'm just logging the failure and returning from this function, so it won't attempt to send the request. But if the service does exist, we'll continue on. Next, we'll need to construct our request message. We do this by creating a shared pointer to the request type that's nested inside of our service type. We need to fill out the fields of the request. In this case, we're setting our x and y coordinates to 2.5. And then we call async sendRequest with the request message we just constructed. Async sendRequest is an asynchronous function, so it's going to return a future that we're storing in the variable called result. We now need to wait for that future to be ready. We can do this by calling waitFor and giving it a timeout. In this case, again, we're using 10 seconds. Here, we can be reasonably certain that if 10 whole seconds have passed without a response from the service server, something seriously wrong has happened. So we'll just log the error and return from this function. But when the server does respond before that 10-second timeout, we can use the get function on our future to get the response message, from which we can extract the name that it assigned to the turtle and log that out to the console. And this is what a basic C++ service client looks like. All that's left to do is to go back to our CMake file, add our new source file to our shared library target, and register that component as an executable node. Having built our workspace and sourced all the necessary setup scripts, we can now run our client alongside the TurtleSim simulator to see the action take place. And sure enough, we see our client wait for the service, see that the service is ready, send the request, and then get the response back and find out that the name is Turtle2. Over in our TurtleSim window, we see our new turtle has shown up in the correct spot. So that's how to write a service client in C++. While the thread handling may be confusing if you're new to it, hopefully the client interface itself makes sense. In the next video, we'll make our own server node.